All right, we want to talk about control. You need to be in control. You need to be in the driver's seat when you're designing an experiment because anything that you forget to control for is what we call a confounding variable, and it makes your results trash. They belong in a trash can. We want the treatment to be the only possible cause that leads to the response. Okay? We want the treatment to be the cause and the response to be the effect. We want to demonstrate causation. And so the treatment needs to be the only possible cause of our response variable. And so anything else that could possibly lead to that response, we want to control for. So let's take a nice simple example, which is treating plants with fertilizer. Okay? The treatment is fertilizer A versus fertilizer B. What other variables lead to growth of plants? Well, sunlight does, right? Getting sun. So if I put treatment A, fertilizer A, in a closet and fertilizer B in direct sunlight, guess what's going to happen? Fertilizer B is going to win. Is it because of the treatment or because of the fact that I was not good with sunlight? Trash, experiment, gone. How about soil? So I plant fertilizer A in sand, fertilizer B in rich soil. Fertilizer B grew so much more. It must be better than fertilizer A. Confounding variable. How about water? Let's water fertilizer A never and fertilizer B daily. Fertilizer B grew so much more, like fertilizer A wilted the plants. Is it because of fertilizer B is a better treatment? It's because you have a confounding variable. What else? How about temperature? Okay, fertilizer A we leave out in the freezing Arctic. Fertilizer B, nice tropical weather. Fertilizer B grew so much better. It must be a better fertilizer. Is that the better treatment? Did the fertilizer cause it? Confounding variable. So you control for these things. You make sure that they get equal sunlight, the same types of soil. You make sure that they get the same amount of water and the same temperatures. Okay, so that is the idea of control. All right, you keep all other factors the same for the subjects. If you have eliminated all other possible causes for a difference in response, the only cause left is the treatment, and we get to conclude cause and effect. Okay, that reminds me of a Sherlock Holmes quote where he says, "If I've eliminated all possible solutions, whatever's left, however improbable, must be the truth." Okay, and that's what we're doing by controlling in our well-designed experiments.